Hey class, how's everything going? So, as popular my videos are, I guess I got a special request to go over homework 1. So, I'm going to kind of go over from scratch and go through the whole setup. So, this is the file that we downloaded from Packet Tracer. So, I'm going to go ahead and grab the file that we downloaded from Packet Tracer earlier and use that. I was just using this to get my notes. And nope. And there we go. Alright, so as we boot this all up, so let's make a note here. So we have a 172.168.0.0/16, so that's a default class B address. Very good. So we need to support 950 hosts, 1260. So what we came up in class, came up with this mask of 255.248.0. So let's kind of figure out some choices here. So we know in this diagram we have one router and we have 1, 2, 3 networks. Okay. So that's pretty straight up, pretty relatively straightforward there. So let's go to the whiteboard. And again, let's always do our number lines. 1, 2, 3, 4, 5, 6, 7, 8. So that's 128, 64, 32, 16, 8, 4, 2, 1. So think of this as the power of 2's. So 2 to the first is 1, 2 to the second is 2. And you're essentially doubling it is the easiest way to think about it. So if we borrow 1 bit, we have basically a 1 and a 0, right? 2 networks. We borrow 2 bits, we get 1, 1, 0, 0 is our different combinations. So, and then we have 1, 0. So we can do that, right? So we could have done 3 bits. So remember, if we're going from the network, we're going to go this way with the bits. So we would be using 128.64, but that would still give us more networks than we'd ever need. Or this will only give us a few networks. So if we want to grow a little bit more networks, because we're going to have more than 1,500, we're going to wind up having like 1,000,000 addresses. So we can make it smaller. So, but I think we wound up agreeing with using 248. So let's look at that, what it would take us to get 248, how many bits we need to use. So let's pull out the calculator and look. So if we take 128 and let's move this over just so we can see that. There we go. And then if I take 128 and add 64, there we go, we got 192. And then if we borrow a 3rd bit, so that would be plus 32. That gives us 225. So then if we add 16, so plus 16. No, we can't have 225. We must have 224 because, or 2. We had to have 240. So somewhere we messed up in our math here. Let's start over again real quick. Because you can't have an odd number for subnet math. So 128 plus 64 plus 32 plus 16 gives us 80, and plus 8. So they gave us 224. So Could we have gone with just the 3 bits? Sure. We would only had exactly 4 networks in a bazillion addresses for each category. So somewhere in class we came up with this number. I don't remember exactly how, but let's see if it fits the bill. So here's how we figure that out. So we know we have our magic number of 256 minus 248, and that gives us 8, because the other 2 zeros, all right? So there we go. So if we take 8 times 256, and again, where are we getting this 256? Because we have this extra octet here that's free. So we multiply it, we get 2,000. And if we go back to our topology, you can see our highest is we have 1,200. So that fits our scenario. All right. So that's good. Let's get back to the calculator, wherever the calculator is at. And now, if we want to figure out how many networks we have, we can divide 256 into 8, and it gives us 32 networks. So we have 32 blocks of addresses that each one supports 2,000 devices. So, this is where you may have some different answers, which is fine, because as long as it fits the bill, that's the answer. If you had a question that said for growth for more hosts or more networks, then you would choose a different answer. So an example, if we said optimize for most networks, well, then this would be the case, because we would have 32 networks, each network holding 2,000. Then if we were shooting for more hosts, then we could have just borrowed the 2 bits and said, okay, and let's see how many networks we would have if we borrowed just the 2 bits. So if we take 128 plus 64, that gives us 92. So if we take 256 minus 192, that would give us 64 times 256, and that would have given us 16,000 addresses. So that would have worked too. So anyways, so now the next step is coming up with our IDs. So we know, because we minus the 256 from 248, we got 8. So we know our network IDs are going to be in increments of 8. So let's go ahead and do this here. So I am starting with 0, 0. Unfortunately, Excel doesn't allow you to do 0.0. So there we go. Now we're going to add it's going to be 0.0 and 16.0. Again, Excel doesn't work with that very well. And then from there, we're going to add 8 to 16. So 16 plus 8 is 24. And then we could go 8 plus 24, 32, and I mean we could keep going if we wanted to, but we don't need to go that many. All we really need is to go to 16, but let's just add another 8 to this mess, and we have 40. Okay, so let's look at our first one. So that would be 8.1, because we're adding from this third octet here. So I did do the colors. Let me make these a little bit bigger font so it's easier to see. Alright. There we go. So let's go 16.1, 24.1, 32.1. We don't need more because we only need 3. So 1, 2, 3, we got more, plenty. So again, we take minus from 16.0, we get 15.255. And if we minus that, minus 1, we get 254. And we get 23 because we minus 1. And then go back in here. And same thing here again. Take 31.255 and 31.254. There we go. So we start with this address block. So again, if you want to do it the long way, you can choose however you like to do it. I like to write everything out first. So yeah, so then we're going to go with router 0 / 0, and then we're going to go with server, and since the server is going to run DNS and all that, so we can just do a / DNS in this particular case. And we can make our range, or it's fine, we can just go with this. This will work. So let's copy this all out, and then here we're going to go with 8, and then again we can use the last digit here, or we can start at the beginning. Doesn't matter, it just which way you want to go. Let's just start with the beginning. So we're going to have 8, then we're going to have 16, so and then we'll have 8 plus 8, that should be 24. Again, we can look here and say, yep, 24. And we can make these just a little smidge wider. So we're going to just pick the first numbers here in the beginning of the range. So again, we're going to use 168.8.1 for the DNS. We're going to do 172.16.2, and then 172.16.16.1, and then 172.16.16.2. 172.16.24.1 and 172.16.251.2. There we go. It's always good to write it out, so this way you know what's going on. Alright, so it doesn't matter which way we tackle this. We can tackle by the router or do the servers. It doesn't matter which order, everything just needs to get done. So how about this? I like to build it piece by piece, so this way we can ping across as we get everything working. So I'll start with the router, or start with the server first, just so we can get an address going and see how things are going. So we're going to go to our desktop, and we're going to leave it static because we're going to run DHCP. You have to run it. So we're going to go with that. Oh, just because it's got that space in it. Doesn't like the space, so I'm going to recopy that. And here we're going to add 248 because that's what we came up with the mask. And we're going to change that to a 1. because that's our gateway. That's our router. So that's the only router in our network. So that will be the gateway. And again, we're going to use the .2, the same address for the server. We're going to point to the DNS because the server, again, needs to be static for things to work. And even though the service is running, the OS needs to know where the service is running. So that's why you have to put it there. It's not that smart. Alright, so we're going to go to service. We're going to go to DHCP. Here we can click on our pool. So again, let's just start with 10. Just give it a couple addresses. And again, we're going to use the default gateway, which would be .1. And .2. We're going to hit save. And we're going to turn on. And now we go to the server here, or this workstation. And then we click dynamic. And if everything's working correctly, it should get on the first address in the pool. There we go. Bingo. So now we're going to go into the CLI. And then we're just going to hit enter. And then since this has no configuration, we're going to just type enable. And then we're going to type into big T. And then we are going to go to interface. And because this is gigabit, because we know it's a 2911, it uses gigabit interface, so we're going to use G0/0 because that's what we made our notes with. And then we're going to do IP address, and then we're going to give it the IP address of our device with our mask. And then we're going to type in no shut. And there we go. Now if everything works correctly, so here's what we're going to do now. You can just up arrow, change the 1, or change that 0 to a 1, because that's what this guy is going to be. This guy is going to be 2. So we're just going to hit enter. Now we're in interface 2. We can just up arrow because I'm just kind of lazy in typing. And now we can just say 16 and do no shut. Perfect. So while that's coming up, we take our PC, go to the command prompt, type in the word ping space 172.16.8.1. There we go. We're pinging that interface. And then if we go to 16.1, there we go. We've now pinged 0.1 interface. So that's perfect. So this PC hit the gateway of the router's interface, and then went halfway through the router and touched the outside of the router's interface. Perfect. Because it's not going to be able to do anything else because we got to configure everything else. So not a big deal. Well, now we're going to go to our server. And since we have already added the router and all that, again, we're going to choose 172.16.16.2. And again, we're going to change the mask to 248. And then here we're going to use the same DNS. And we're going to use 1 for the router. Perfect. And then we're going to go to service, go to DHCP, and then we're going to change that so it starts with a 10, just for uniformity. And we're going to use the gateway, because remember the gateway for network 2 is the 0.1 interface, so we're going to put that in there. So that's going to be .1, because that's what we labeled everything. .2 would be the DNS. We're going to hit save. So now it has all the information. and we're going to hit on. And now we're going to check this computer here. We're going to go here, change this to DHCP again. Here we got a 10 address. Perfect. So now from here we can go to the command prompt and type in ping 172.16.8.10. So we've gone from PC1 through the router to PC0. Perfect. All right. Now we'll pick the. It doesn't matter. I mean, we could have you could have gone in here and IP'd all three interfaces of this, and then done all these, or you could have done all these first and do this. There's not necessarily an order you have to do it in. I just like to build each segment and make sure that it can ping across, and then build to the next one and build to the next one. That's just how I tick. But you could have put these all together and then did this and then ping. I just like to ping across as I get things working, so this way it's a little bit easier for troubleshooting if things are not working. Alright, so now we're on server 2. So here we go. We're going to go back to the PC. We're going to use the third ID here that we came up with, which is 172. So you're used to working with class C addresses at home, 24, and we're going to say .2. So now I'm going to just copy that over. Again, we're going to change the third octet to match what our plans are. And again, we're going to point to ourselves for DNS, and then we're going to point to this interface as our gateway, and we're going to assign that 24.1, so that's going to be the information for it. And then, okay, we're going to go to DHCP, and we're going to change that to a 1 to match what our configuration says. And we're going to start with a 10 because we don't want to have addresses in line. So there we go. We're going to go to the router, and we're still in the same spot, so we can just up arrow to interface gig and change it from 0/1 to 0/2, and then we can just up arrow to the IP, and again we can change this to 24, so that's 172.16.24.1 with the default mask, and then again do a no shunt. And as we wait for that to come up, we can bring the PC up and now test the DHCP. There we go. See, I made a mistake there. See, because now it has a .1, the interface of the routers 1, and I did not save the default gateway. So let's go back here and let's go to our DHCP. So it didn't save the settings, so I did not hit save. So there we go. Our default gateway is going to be a 1. Our DNS will be a 2. Here we're going to be a 10. And we're going to hit save again. Let's turn this off. Turn it back on, just to be on the safe side. Go back to PC2. And again, these are common mistakes that we do. We're all not perfect. Again, there we go, 172.16.24. That matches the valid address range that's on this network. And we're going to go back to the command prompt, and we're going to type in ping 172.16.8.10. There we go. We're pinging PC2 is pinging PC0, and then we're going to change that to 16. And we can see that we can ping all three devices, can ping each other. So the switches are not properly configured, so they're not going to be able to ping each other. You know, we learned a little bit of that last week. So that pretty much concludes the Subnet Problem 1. All right, I'll catch you guys in class. Bye.